So if you're ready to let go of certainty, step into the unknown and question not just what's out there, but who you truly are. Tap like, hit, subscribe and follow the thread into the deepest recesses of the self, where reality begins to fracture. A particle can be in two places at once, until you look. Imagine standing in front of a hallway full of locked doors, each one identical, silent, and unmoving. You're told behind one of them lies your future, but the only way to know which one is real is to open one and watch all the others vanish. That's quantum mechanics, not metaphorically, literally, because at the smallest scales of nature, the world doesn't behave the way your intuition wants it to. Reality is not a fixed path you're walking down, but a shifting landscape that rearranges itself the moment you take a step. And nowhere is this more strange, more mind-warping, than in the simple truth that a single particle, a thing so small it borders on nothingness, can be in two places at the same time. Not metaphorically, not figuratively. Actually, until your attention collapses the possibility into one reality. This isn't science fiction, it's science fact, and it challenges not only your understanding of matter, but your sense of meaning, of cause and effect, of what it even means for something to be real. You were raised to believe that the universe is out there, independent, objective, stable. But quantum physics says otherwise. It whispers a deeper story, one that doesn't just tweak your understanding of the cosmos, but rips it apart and reconstructs it into something far more intimate. A world where the observer and the observed are inseparably tangled, where reality itself waits for you to decide what it is. They taught you that reality is solid, that things exist in one place at a time, that you can measure, predict, and confirm the world like a machine built on logic and causality. But that worldview dissolves when you shrink your gaze down to the level of atoms and subatomic particles. There, things stop acting like things. A particle isn't a dot in space. It's a smear of probability, a cloud of potentialities. It doesn't sit quietly waiting to be discovered. It dances in all the places it could be, simultaneously. Until you look, until you measure, until you interfere. And when you do, the particle chooses, randomly, capriciously, instantly. The wave of possibilities collapses. The many paths reduce to one. And that act of collapsing, of pinning down reality into a single state, is triggered not by time, or gravity, or fate, but by something astonishing: your observation. The very act of seeing alters the scene. This is not philosophy. This is experimental physics, proven again and again. Take the famous double-slit experiment. When particles like electrons are fired toward a wall with two slits, they create an interference pattern, not like marbles, but like waves, as if each particle went through both slits at once and interfered with itself. But when detectors are placed to observe which slit the particle passes through, the interference vanishes. The particle acts like a marble again, choosing just one slit. Observation destroys the wave behavior. Consciousness changes the outcome. And in this lies the heart of the paradox. Reality does not simply exist, it waits. But what does that even mean? That reality is passive? That the universe is undecided until we ask a question? It seems impossible, and yet the evidence is undeniable. In the quantum world, possibility is more fundamental than actuality. The particle does not have a definite position until you observe it. It exists in a superposition, a blend of every possible state smeared across the spectrum of existence like paint across a canvas not yet touched by a brush. And when you do look, when you do measure, when you do ask, it's as if the canvas freezes, the paint settles, the picture completes, but not before, not without you. You are part of the painting process. You are not separate from the world you observe. You are embedded in it, entangled with it, creating it as much as discovering it. And this fact, that your awareness might help shape the outcome, does not just shake physics. It reshapes metaphysics. It invites a new understanding of self and world, of identity and time, of what it means to exist at all. Because if a particle can be in two places at once, if the universe allows such ambiguity, then perhaps your reality is not singular either. Perhaps you too exist in superposition, hovering between the lives you've lived and the ones you haven't yet dared to choose. Think about decisions you didn't make, roads you didn't walk, people you never met, versions of you that flickered briefly in the fog of possibility and then disappeared when you chose something else. What if those versions weren't fiction? What if, in some quantum sense, they still echo, still hum in the background of your being? What if identity is not a fixed story, but a cloud of probabilities collapsing moment by moment as you decide who you are? If a particle doesn't become real until it's observed, what does that say about the self? Is the you of today any more real than the one you could become tomorrow? Maybe the very act of deciding, of looking inward, is its own kind of quantum measurement, and maybe the fear that comes with choice, the anxiety of committing to one path, isn't just psychological, maybe it's ontological, maybe it's grief for the collapsing of parallel selves, maybe it's the weight of watching infinite futures condense into one. And in that grief, there is also wonder. Because to choose is to create. To observe is to collapse possibility into presence. To live is to carve meaning out of mystery. Even the very nature of time unravels under this quantum lens. In classical physics, time is a line, past, present, future, fixed. But in the quantum realm, time doesn't behave. A particle can affect its own past. The future can rewrite the present. Causality loops and twists like a Mobius strip, and suddenly, your life is no longer a sequence but a wave, a pattern, a field of potential futures interfering with each other in ways you may never fully understand. And so we return to that particle, the one in two places. It's not just a curiosity, it's a doorway, a clue, a shimmering crack in the facade of the ordinary. It says, the world is not what it seems. You are not what you seem. And if you dare to look, really look, you will find that the act of looking changes everything. Not just the object, not just the moment, but you, the observer, the maker, the co-creator of reality. So what do we do with this knowledge? Do we freeze in the face of infinite possibility? Do we mourn the paths not taken? Or do we lean into it? Embrace the ambiguity, the freedom, the terror and beauty of a universe that responds to our gaze. Perhaps the lesson is not to seek certainty, but to become comfortable in the unknown. To make peace with a reality that doesn't exist until you engage with it. To find courage in the collapse of the wave, knowing that every choice you make is both a death and a birth, a letting go and a becoming. Because in the quantum world, looking is not passive. It's generative. It's alchemical. It takes the ghostly and makes it real. And perhaps that's your role, not to observe life from the sidelines, but to step into it fully, knowing that your attention matters, your presence matters, your decisions, however small, ripple outward into the fabric of what is. And so the paradox resolves, not in clarity, but in coexistence. A particle can be in two places at once, until you look. And you too can hover between who you were and who you might become, until you choose, until you dare, until you open the door and accept that reality is not given, it is made, in the looking, in the asking, in the wild, uncertain act of being aware. Because maybe, just maybe, awareness is not something that happens inside the universe, but something the universe does when it becomes you. The delayed choice experiment. The future decides the past. What if you wrote the ending of a story before the beginning was ever put to paper, and the plot lines obediently rearranged themselves to match the twist you hadn't yet chosen? What if the ink in the opening sentence only dried after you'd flipped to the final page? That's the logic-defying realm you step into with the delayed choice experiment. A place where the future doesn't just unfold from the past, it loops back and reconfigures it. In this world, causality is not a straight line from A to B, but a shimmering web of influence stretching forward and backward in time, where your decision in the present appears to ripple into the past, rewriting what should already be set in stone. You've spent your life believing that what has happened is fixed, that the past is the foundation upon which everything else is built. But quantum physics cracks that foundation open and whispers a far more unsettling possibility, that the present might edit the past, and the future might cast shadows backward across time itself. Imagine reaching out to catch a falling glass, only to find that your hand had already moved in response a second earlier, as if time had bent to meet your intention before it fully formed. The delayed choice experiment doesn't just suggest this, it demonstrates it empirically, consistently, and irreversibly. And the deeper you look into it, the more the illusion of linear time unravels, revealing a universe in which chronology is optional, in which the act of choosing doesn't merely affect what will happen, but what already happened. To understand this, you first need to forget everything you know about time. We're trained to experience time as a conveyor belt, always moving forward, never pausing, never reversing. The past is gone, the future unknown, the present fleeting and always consumed by the next moment. But in quantum mechanics, time is not a simple arrow. It's a field of interdependencies. The delayed choice experiment begins with the humble photon, one particle of light, and a setup similar to the infamous double-slit experiment. In that classic setup, photons pass through two slits and strike a detector, creating either an phase interference pattern, if they act like waves, or two distinct clusters, if they act like particles. What makes the delayed choice version so disturbing is the timing. The choice of whether to observe the photon as a particle or a wave is made after it has already passed through the slits. And yet, the photon behaves according to the decision made afterward. If the observer chooses to detect which slit it passed through, it behaves as a particle, having gone through one slit. But if the observer chooses not to detect, it acts like a wave, interfering with itself as if it had gone through both slits. The twist. This decision is made after the photon should have already decided what it was. It's as if your present observation reaches back in time and changes the past state of the photon, retroactively deciding what it did. This isn't metaphor, this is experimental data. So what does this mean for reality? For you? For everything you think is true about cause and effect? It means that the world may not be constructed in the orderly sequence we imagine. That time may not be an independent backdrop against which events unfold. Instead, the entire fabric of reality might be woven from correlations, from a vast, interconnected net of outcomes that align not based on when things happen, but on how they are eventually observed. The photon's path isn't determined when it travels, it's determined when it's measured, which means the universe doesn't commit to a single past until the present requires it to. Now think about that in human terms. Think about how often you reinterpret your own past based on what you now know. How a painful memory becomes a moment of growth only in hindsight. How something meaningless takes on significance only after its echo is heard years later. Maybe this isn't just psychology, maybe it's physics. Maybe the brain's tendency to reframe the past isn't a glitch. It's a reflection of how reality itself behaves. Maybe memory isn't a static archive but a quantum process, one that reshapes the narrative every time it is accessed, folding the future into the past, like hands shaping clay from both ends at once. And if this is true, if observation truly reaches backward, then what happens to responsibility? To choice? To identity? We like to think we are the products of our pasts, that who we are was shaped by the sequence of events that led us here. But what if the past is not finished? What if it's fluid, responsive, still vulnerable to the weight of our present awareness? What if the act of understanding, of interpreting, is not a passive reflection, but an act of co-creation with time itself? Then every new insight doesn't just color your memories, it alters them. Every moment of presence becomes a ripple that rewrites the context of what has already occurred. You are not merely walking forward on a path laid out behind you. You are sculpting the road you've already walked. And perhaps This is the deepest implication of the delayed choice experiment, that time is not something you move through, but something you generate through your engagement. That reality is not fixed until you engage with it, not just in space, but in time. Consider the implications. If the future can change the past at the quantum level, what does that say about destiny? About free will? You might imagine your life as a line drawn from birth to death, but perhaps it's more like a painting still being brushed from both directions. Your choices now don't just carve a future, they cast meaning backward. They highlight certain memories, diminish others. They reach into your past and alter the emotional resonance of things long since done. And maybe, on a level far beyond introspection, they literally shift the physical chain of events that led here. If the fabric of the universe holds space for such retrocausality, then your story is not yet finished, even in the parts you thought were over. Every moment becomes a negotiation between what is and what was, and observation is the bridge. This doesn't mean you control time like a god. It means you participate in it like a partner. You are part of the machinery, not outside the clock, but in the gears, turning the hands from both ends. And still, this leaves us with the haunting question. If the future can decide the past, then what is the now? What is this moment you call the present? Perhaps it is not a thin slice between what has been and what will be, but a crucible where both are forged, a meeting point where the past collapses into a single story only when the future has made its demands. And perhaps this explains the sensation of déjà vu, of prophetic dreams, of intuitions that feel impossible to justify. Not fantasy, not coincidence, but subtle entanglements across time, echoes moving in both directions, signals from outcomes not yet realized, rewriting the context of what came before. And if this sounds like science fiction, remember, the delayed choice experiment is not a theory. It's an observation, repeatable, measurable, real. The photon behaves retroactively based on a future choice. The universe answers questions before they're asked, and if a single particle can rewrite its past to match a future decision, then perhaps so can you. Let this truth change the way you see your story. The moments you regret may not be as fixed as you think. The traumas, the mistakes, the silences, they might still be open, still waiting for a different context to collapse into, still capable of becoming something new under the light of a present intention. Maybe healing is not rewriting the story, but observing it differently, choosing to measure it in a way that changes its form. Just like the photon, just like time. Maybe the past isn't the prison you assumed. It's the raw material of meaning, sculpted not by what happened, but by what you choose to make of it now. And maybe, in some quiet, impossible way, the universe is always waiting for you to choose, not just what will happen, but what already has. Observing something changes its reality. You walk into a room full of mirrors, but none of them reflect you back until you make a move. You raise your hand, and only then does the image respond. You tilt your head, and the mirror scrambles, reconfigures, recalculates before offering a version of you that wasn't there a moment ago. Now imagine that the world itself behaves like that mirror, not passively reflecting, but actively composing itself in reaction to your attention. This is the haunting elegance of the observer effect. The idea that the simple act of watching something, of focusing your awareness upon it, fundamentally changes what it is. Not metaphorically, not symbolically, but physically, tangibly, empirically. In the realm of quantum mechanics, particles don't merely sit around waiting to be seen. They are unsettled by your curiosity, reshaped by your gaze. They live in a haze of probabilistic possibilities until your measurement pins them down into a single outcome, collapsing their ambiguity into a precise state. But the true disruption runs deeper than physics textbooks let on. Because this isn't just about electrons in a lab. This is about you, your relationships, your choices, your identity. This is about how everything you observe, people, events, memories, bears the fingerprints of your perception. The observer effect isn't some obscure feature of subatomic, weirdness. It's a mirror held up to the nature of awareness itself. And once you see it, once you understand that observation is not innocent, but interventionist, you begin to realize you've never seen the world as it is, only as it becomes in response to you. In classical physics, reality is assumed to be independent of the observer. The moon is in the sky, whether or not you glance up to see it. A tree falls in the forest and makes a sound, regardless of whether anyone is listening. But the quantum world rebels against that certainty. In it, particles exist not as fixed entities, but as a field of probabilities. They occupy multiple states at once, until observed. Then, and only then, does the particle choose a state, collapsing from superposition into a measurable result. The experiment that revealed this, the famous double-slit experiment, is one of the most elegant and disturbing in all of science. Fire particles, one at a time, at a barrier with two slits, and you get an interference pattern on the screen behind, a signature of wave-like behavior. It's as if the particle went through both slits at once. But install a detector to observe which slit the particle passes through, and the interference vanishes. The pattern changes. The particle decides to go through one slit. The wave collapses into a dot. The act of observing, not touching, not disturbing, merely knowing, alters the outcome. This is not theoretical. This is repeatable, measurable, and deeply unsettling. The particle seems to behave differently based on whether or not someone is watching, as if the universe is reluctant to define itself until you ask, as if the answer only exists once the question is posed. But if matter itself waits for your observation to make a decision, what does that say about the rest of your life? About your relationships, your fears, your memories? Think of the times you've watched someone across a crowded room and seen them transform under your gaze. The way a friend speaks more carefully when they know you're listening. The way your own posture shifts when you catch your reflection. Observation is not neutral. It is catalytic, and you feel it in your bones. You've walked into rooms where you were watched and felt your skin bristle with hyper-awareness. You've been in conversations where the act of being seen made you more articulate or more performative. This is not psychology alone. This is physics leaking into the soul. Because you're not just changing your behavior when observed, you're participating in a loop that changes what's real. That version of you under scrutiny is not the same as the one in solitude. Just like the particle, you collapse into a specific self the moment attention is applied. And this collapse is not a distortion. It is your most real state in that moment. The observer calls forth the observed. The mirror doesn't just reflect. It generates. Now consider this on the level of memory. When you recall a moment from your past, you don't retrieve it like a file. You recreate it. You reconstruct it through the lens of who you are now, from the vantage point of your present awareness. Neuroscience shows us that memories are not stable. They are rewritten each time they're recalled. But what if that's more than a brain quirk? What if it's a manifestation of the observer effect in consciousness? Each time you revisit a memory, you're not just re-experiencing it, you're changing it, reformatting it. The past does not lie dormant. It flutters in a state of quantum ambiguity until you observe it again and lock it into new form. You are the observer collapsing your own timeline into narrative coherence. You are not just living your story, you are authoring its previous chapters in real time. And this isn't just about nostalgia, it's about trauma, about healing, about meaning. Because it suggests that nothing in your past is unchangeable, that every event, every regret, every wound still pulses in a state of interpretive fluidity, waiting for the next act of observation to define its meaning. You don't need to rewrite the facts, you only need to look at them differently. And in that shift, everything changes. This realization also reconfigures how we view others. When you observe someone, not casually but deeply, you affect who they become. Attention is a form of energy transfer. It tells the observed, I see you, and in seeing, I confirm your existence. The gaze stabilizes reality, but it also narrows it. To look at someone is to reduce their possibilities. to nudge them toward one of their many potential selves. This is why we're drawn to those who see us with kindness, because their observation collapses us into a version of ourselves we want to become. And this is why surveillance, even when passive, is oppressive, because it collapses the observed into caricature, into something less fluid, less free. The eye shapes the object. The watcher changes the watched. And if this feels poetic, remember, it is also physics. At the quantum level, the measuring device is part of the system. There is no outside, no objectivity, no clean separation between the observer and the experiment. The same is true in life. You are never uninvolved. You are never merely witnessing. You are always, inevitably, participating. So what does it mean to live ethically in such a world? A world where every glance is a force, every thought a nudge, every belief a sculptor's tool. It means taking responsibility for your perceptions, for the way you look at the world, for the reality you help construct. Because you are not just observing culture, you are co-authoring it. You are not just witnessing suffering. You are either collapsing it into permanence or shifting it into something else through your response. And this is both terrifying and liberating. Terrifying because it means you're never off the hook. Liberating because it means you are never powerless. Your gaze is not passive. It is an act of creation. And if you direct it with care, with compassion, with curiosity, with reverence, you can shape the world not as it is, but as it longs to become. You can collapse it into kindness, into connection, into coherence. And yet we are trained to think of truth as something we uncover, as if the world lies out there, waiting to be found, and our job is to remove the layers of distortion and finally see it for what it is. But maybe truth doesn't pre-exist our awareness. Maybe it crystallizes under the heat of our attention, like frost forming on glass. Maybe we do not find truth. Maybe we birth it. Each act of observation, a kind of midwifery. Each question not a request for information, but a lever that rearranges the answer itself. And this isn't to say that reality is illusion or that facts are fiction. It's to say that reality is participatory, that knowledge is relational, that even the hardest edges of the world are softened by the brush of our consciousness. And once you accept that, you begin to move differently. You look more gently, you listen more deeply, because you know that the very act of doing so is transformative, not just for what you observe, but for who you become. So next time you think you're simply watching, pausing, assessing, analyzing, remember the mirrors, remember the particles. Remember that nothing you see is untouched by your seeing, that your awareness is not an idle spectator, but an instrument of reality. You are the ripple in the pond that starts the waves. You are the question that rewrites the past. You are the observer collapsing ambiguity into meaning. And every moment you pay attention, you leave a mark, not just on what is seen, but on the unseen field from which all things emerge. The world, then, is not a stage set before your arrival. It is a script that adapts to your gaze, a story still being written every time you open your eyes. And maybe, just maybe, the most radical thing you can do in a world like this is to look with love. Quantum entanglement. Particles are linked across the universe. Suppose you and another person each hold half of an ancient shattered mirror, two jagged pieces that once belonged to the same whole. You walk away in opposite directions, unaware that the reflections within each shard remain mysteriously connected. One day, as you tilt your fragment ever so slightly, the angle of light changes not only on your side, but, impossibly, on theirs, miles away. Not through signal, not through space, not even through time, but instantly, silently, as if the glass still believes it is unbroken. That's the essence of quantum entanglement, one of the most baffling and beautiful features of our universe. It tells us that particles once joined remain linked forever, no matter how far they drift apart. Not metaphorically, not poetically, but physically, at a level so deep it defies our language. When one of these entangled particles changes state, the other does too. immediately, across vast distances, faster than the speed of light, as if distance were irrelevant, as if space itself were an illusion, as if the universe had no local parts, but only relationships echoing through an invisible web of connection. This is not a metaphorical suggestion. This is the cold, crisp reality of quantum physics. And yet, what it implies is warmer, more intimate, more human than we were ever taught to expect. That separation may be an illusion, that distance may be negotiable, that perhaps everything, everyone, is entangled at a level we are only just beginning to glimpse. Entanglement begins innocently enough. Two particles interact, they collide or are created in a shared event, and they become entangled, meaning their states are no longer independent. Measure one, and the other's state is instantly known. But it's more than just information sharing. It's not that one particle tells the other what to do. It's that both particles are expressions of the same deeper reality, the same joint state. To speak of them as separate is already to lie. Einstein, troubled by this, famously called it spooky action at a distance, because it seemed to violate the speed limit of the cosmos, the sacred law that nothing can travel faster than light. And yet, time and again, entangled particles behaved in lockstep, their outcomes correlated in ways no classical signal could explain. Experiments by Bell, Aspect, and others confirmed what Einstein resisted. The universe is not built from independent objects, but from interwoven patterns, holistic configurations, entangled states that defy locality. In other words, the universe does not consist of things in space. It consists of space-spanning relationships, like spiderwebs stretching across eternity, vibrating together without regard for distance. And here's the truly radical part. This entanglement does not fade. With separation, you can send one particle to the other side of the Earth, or the galaxy, and their connection remains intact. Entanglement is not like a thread that stretches and thins with distance. It's more like two ends of a dimension you don't understand, where proximity isn't about closeness, but about correlation. Space, as you know it, is background noise to their bond. The measurement of one instantaneously determines the outcome of the other, not through signal, but through a kind of shared being. This violates every instinct we have about how the world should work. We think in terms of cause and effect, in terms of here and there. But quantum mechanics laughs at those distinctions. It suggests a universe where parts are illusions, where the whole is primary, and where what happens to one piece is inseparable from what happens to another, regardless of space, regardless of time. And if that sounds philosophical, it should, because quantum entanglement doesn't just challenge our physics, it challenges our ontology. It challenges what it means to be separate, to be individual, to be alone. Let's pull this into your world. Imagine your emotions entangled with another's across distance. You think of someone you haven't spoken to in years, and a moment later, they call. Coincidence? Maybe. But what if your thoughts, your choices, your inner world are not sealed inside your skull, but radiate into a shared field? What if consciousness itself is entangled? Some physicists speculate that entanglement is the basis of spacetime itself, that the geometry of reality arises from patterns of quantum connection. If true, then the separation you feel from others is not fundamental. It's constructed, an illusion born of perspective. And if so, then love, empathy, grief, these aren't just feelings, they're evidence. Evidence that our boundaries are porous, that our being extends beyond our bodies, that we resonate with others not metaphorically, but literally, at the deepest levels of physical law. You are not a closed system. You are an open node in a cosmic lattice. Your choices, your observations, your feelings, they ripple outward in ways no eye can see. And the same is true of everyone you've ever touched. We are not alone. We are entangled. And this raises a difficult, profound question. If your actions affect others in ways you cannot perceive, what responsibility do you carry? If your internal state is entangled with the world's unfolding, How carefully must you tend to it? The observer effect showed us that watching changes what is seen. Entanglement shows us that being is already shared. So what kind of world are you collapsing into being through your attention, your presence, your pain? We spend our lives trying to protect our independence, to fortify the walls between self and other. But entanglement offers a counter-truth, that your fate is tied to others. That isolation is a fiction. That every decision you make participates in the state of a larger whole. And this isn't a soft poetic gesture. It's a hard mathematical claim. The universe is built from entanglement. Reality itself may be emergent from these correlations. There is no fundamental thing, only relationships. The basic unit of reality is not a particle, but a connection. This is not just physics. It is a revolution in worldview. Entanglement asks us to abandon the myth of separateness, not just between particles, but between people, between moments, between intentions and consequences. It suggests that when you suffer, someone else trembles. That when you hope, the universe brightens, not metaphorically, but in measurable, entangled states. And perhaps this is why we cry in movies, why we flinch at the pain of strangers, why we feel when a loved one enters the room without seeing them, because the threads that link us are not imaginary. They are quantum. We are haunted not by ghosts, but by the physics of connection. And the more you open to this possibility, the more the world changes shape. You stop seeing objects and start seeing patterns. You stop seeking control and start seeking coherence. You begin to listen for the harmony between things, instead of the boundaries that separate them. But how far does this go? Could the entire universe be one grand entangled system? Could the Big Bang have birthed not billions of particles, but one universal wave function, entangled across all of space and time? In that view, you are not a being in the universe. You are the universe, experiencing itself through a particular lens. Your memories, your choices, your relationships, these are not isolated data points. They are coordinates in a web that spans stars. And this leads to an unsettling possibility, that there may be no randomness, only correlation, that your thoughts are connected to others in ways deeper than language, that your perception is not confined to your eyes, that intuition, coincidence, synchronicity, these are not quirks. They are glimpses of the entangled whole. So what do you do with this? How do you live in a world where everything is connected at a level beyond comprehension? You begin by looking, again, at the ones around you, not as separate minds, but as shared participants in a dance too complex to map. You begin to treat your words, your moods, your attention not as private acts, but as vibrations sent down an infinite string. You stop asking, is this mine or theirs? And start asking, what are we creating together? Because in an entangled universe, you don't get to act alone. Every gesture is a duet. Every thought is a chord. Every breath is an echo. And when you see this, truly see it, something inside you shifts. The loneliness begins to crack. The silence begins to hum. And you realize that the world has always been whispering. You are not alone. You were never alone. You couldn't be alone even if you tried. A particle can take every path until it's observed. Imagine you're standing at a grand crossroads at midnight, surrounded by countless roads, each stretching into a different possibility. Foggy mountain passes, sunlit highways, ancient forest trails, crumbling city streets, and even invisible paths that twist upward into the stars. You haven't moved yet, but somehow you've taken them all. In a way that defies common sense, you've walked every trail, arrived at every destination, lived every outcome. But then, just as you take your first real step, a light flicks on above you. A camera clicks, observation arrives, and in that moment, the illusion vanishes. The other paths collapse into silence, and only one road remains beneath your feet, the one that now seems inevitable. This is not a metaphor for life. This is quantum reality. At the smallest scales, Particles do not travel a single tidy path from point A to point B. Instead, they explore every possible route simultaneously in a kind of shimmering super-reality that unfolds beyond space and time. Richard Feynman, one of the pioneers of quantum theory, introduced the path integral formulation of quantum mechanics to describe this bewildering behavior. According to it, a quantum particle like an electron doesn't choose a single trajectory. It samples all trajectories, even absurd ones, like circling the galaxy before arriving at its destination. Every path contributes to the particle's final state, like a grand cosmic orchestra of probability, until a measurement, the act of observation, collapses the symphony into a single note. But what does it mean to say that a particle takes every path? It isn't poetry, it's math. In quantum mechanics, the probability of finding a particle in a particular state is calculated by summing over all possible paths it could take to get there. These paths don't merely represent our ignorance about the particle's motion. They represent real calculable contributions to its behavior. In classical physics, if you throw a baseball, it follows a predictable arc based on gravity and momentum. But if you were to throw a quantum baseball, a subatomic particle, it would travel not just the arc, but every conceivable arc at once. It would roll across the floor, loop around the moon, and dive through the Earth, all in one breathless quantum blur. And yet, we never see such chaos. When we measure the particle, when we force it to reveal itself, it offers us only one answer. Only one path survives the gaze. And so the others disappear, not like discarded options, but like shadows that were never meant to be touched by light. This concept cuts into the heart of how we define reality. In our daily lives, we're trained to think in binaries. A thing either happens or it doesn't. A road is either taken or not. A decision is either made or left behind. But quantum physics suggests a deeper, stranger truth. That possibility is not erased by indecision, but kept alive by it. That, until we look, reality itself is a cloud of potential, waiting to crystallize. This is not some abstract philosophical stance. It's borne out by decades of experimental evidence, from the double-slit experiment to quantum interference, patterns. When particles are not measured, they interfere with themselves, as if they really are taking multiple paths. But once you check, once you peek behind the curtain, that interference vanishes. The particle chooses, or rather, the universe chooses for it. And what's even more mysterious is that your act of observation is what forces that choice. Not the measuring device, not the lab. You. Consciousness, in some interpretations, becomes a participant in reality itself, collapsing the wave function, carving out one path from the sea of maybe. This has implications far beyond physics. Think of your own life. How many paths have you imagined? Careers not taken, words not spoken, cities never visited, people you almost loved. In the quantum realm, the particle gets to try all of them, simultaneously. But in your world, you get one timeline, one unfolding. And yet, the resemblance lingers. Perhaps possibility never truly dies. Perhaps the unseen choices still hum beneath the surface of what is. There is a lesson in that, not just about nature, but about awareness. Before you decide, the world is fluid. After you look, it congeals. So what is the cost of attention? What do you erase by choosing to see? Could your gaze itself be an instrument of creation and destruction? Could every observation you make be a quiet act of cosmic editing, trimming the multiverse into a single palatable thread? Let's return to the metaphor, the crossroads. When you stand there before observation, you are everything. You are the dreamer and the dream, the walker and the watcher. But the moment you choose, the other versions of you, the ones that took different roads, slip away. And yet, quantum mechanics suggests that in some interpretations, like the many worlds theory, those versions don't vanish. They simply diverge, split off, continue on in universes parallel to yours, where the particle took a different path and you made a different choice. That may sound like science fiction, but it's an interpretation built to preserve the totality of quantum paths. If so, then every decision you make isn't the closure of possibility. It's the birth of new worlds. Every step forward is a kind of branching, a ripple in an infinite field of becoming. The quantum particle teaches us that even when we choose, we are still part of the whole, of everything that might have been. Still, in our observed universe, we only see one path. The others do not show up in our equations. They vanish, or hide, or live on in dimensions we cannot reach. But their influence is not lost. They shape the probabilities. They create interference. They are, in a sense, ghosts, real but unseeable. And perhaps our lives are shaped by similar ghosts. The shadow of the person you could have become haunts your footsteps. The echo of the love you never pursued lingers in your chest. The memory of a decision never made shapes how you make the next one. We are, all of us, shaped by what didn't happen. And maybe that's not a flaw in reality. Maybe it's a feature. Maybe quantum mechanics doesn't just allow for multiple paths. It requires them in order for any single one to exist. Like a painting where every brushstroke matters, even those you cover up. Like music, where the silent notes give meaning to the ones you hear. What doesn't happen is as crucial as what does. And yet, with all this mind-bending beauty, one question remains. What does it mean to observe? Is it merely the act of recording, or something deeper? Does the universe care whether a machine sees a particle, or does it require consciousness? Some interpretations say no, others whisper yes. But either way, it is the act of narrowing that changes things. Observation collapses, attention selects. And in doing so, it changes the story. Perhaps this is the ultimate power of awareness, not just to witness reality, but to sculpt it. Not to uncover what is, but to help determine it. The quantum particle, in its pre-observed state, holds the lesson. The world is not fixed, not solid, not singular. It is a canvas of possibilities, and your gaze is the brush. So the next time you hesitate at a decision, remember the particle. Remember that it once moved in all directions at once. Remember that it never stopped until it was seen. And ask yourself, what might still be possible if you dared to not look too soon? Superposition. Things exist in all states at once. Picture a violin string suspended in absolute stillness, hovering in a void where time hasn't yet chosen a direction and silence holds its breath. And yet somehow, it vibrates with every note it could ever play. A symphony of futures resides in its potential, but none have been heard, none yet chosen. It exists in a state of haunting contradiction, perfectly quiet and infinitely loud. That is the paradox of superposition, the idea that a particle, a thing, a moment, a state of being, can simultaneously exist in multiple realities, not as a blur between them, but as all of them at once, until something, someone, dares to look. Before the gaze, the world is a superposition of everything it could be. Yes and no, light and dark, awake and dreaming. A coin in midair is not heads or tails. It is both, spinning, uncommitted, timeless. In quantum mechanics, this isn't just metaphor. It's the governing rule. At the microscopic level, electrons, photons, even entire molecules can occupy more than one state, more than one location, spin, energy level, path, identity, simultaneously. They exist as a wave of probabilities, a smeared out canvas of maybes, and it's only upon measurement, observation, awareness, call it what you will, that the wave function collapses and the system chooses a definite outcome. But the act of collapsing is not merely a resolution, it is a sacrifice. To exist in one form, the others must die. Superposition is not a failure of understanding. It is a failure of classical intuition. In the macroscopic world we inhabit, the world of stones, planets, trees, and chairs, things seem to have a single identity. Your coffee cup does not both exist and not exist on the table. Your cat is either sleeping or awake. And yet, in the quantum world, the very act of having only one reality is the anomaly. Schrödinger's cat, that infamous, misunderstood feline, was never meant to be a riddle for children. It was a philosophical scream wrapped in absurdity. The cat, sealed in a box with a quantum mechanism that could trigger poison, is both dead and alive, not in a metaphorical sense, but in the genuine physics of superposition. Until the box is opened, the quantum system inside doesn't decide. It continues to occupy both possibilities, both narratives, both fates. This isn't a flaw. This is the rulebook. Our problem is that we live outside the box and demand the cat pick a side. But what if the universe itself doesn't share our urgency for certainty? Superposition implies that reality is not a line but a cloud, not a point but a field. Every particle, every entity exists as a range of overlapping possibilities, each with its own amplitude, each with its own voice in the final harmony we call now. This principle lies at the heart of quantum computing, where bits are no longer limited to 0 or 1, but can be both, creating a parallelism so vast it threatens to rewrite what we think is computable. But beyond the laboratory, beyond the equations, superposition teaches us something deeply uncomfortable about the nature of existence, that clarity may be an illusion created by ignorance, that the world is not singular until it is forced to be, and that perhaps we too are not as singular as we believe. Have you ever felt torn between two decisions, as though both versions of yourself, the one who stays and the one who leaves, the one who speaks up and the one who stays silent, were real? In the world we inhabit, we're told to choose, to collapse, to be one thing. But what if the multitudes within you are all real, all humming in your psyche like unresolved quantum states? What if the process of living is not about choosing a single self, but collapsing into one version, moment by moment, knowing that others still ripple through the echo chamber of what might have been? Superposition is not just a physical condition, it is an existential condition. You are a symphony of selves, each possible, each valid, each waiting to be observed. And the tragedy, or perhaps the beauty, is that to become one, you must silence the others. In the physical world, superposition is fragile. Interactions with the environment, what physicists call decoherence, destroy it. The moment a quantum system is touched, bumped, illuminated, its delicate balance shatters. The particle falls into place. The note is played. And yet, until that interference, it holds a paradoxical power. It is more than real. It is everything real could be. In that light, one could argue that silence is more than the absence of sound. It is the superposition of all music not yet played, that a blank canvas is more than emptiness. It is the potential for all images, that a human life, unlived, is not nothing, but everything. Until the brush touches the canvas, until the note is struck, until the measurement is made, the universe itself remains an unresolved chord. There's a humility in accepting superposition, a surrender of the ego's need for answers. We like certainty. We crave definition. We want to point and say, that is the truth. But quantum physics replies, truth is the distribution. Reality is the amplitude. Existence is the possibility. And that unsettling whisper has implications, not just for physics, but for meaning, for morality, for identity. Can we really condemn or praise what collapses, knowing it emerged from a sea of might-have-beens? Are our actions definitive, or merely the visible outcome of invisible quantum options? Is there a better version of you in superposition right now? Kinder, braver, more honest? And if so, what would it take to become them? Is it awareness? Is it risk? Is it observation? In a strange way, superposition is the most compassionate theory in physics. It says, you are not defined by your last choice. You are not reduced to one version. You are many things. You are many truths. And only context, Only the observer, only the moment, decides which one takes form. This is terrifying, of course. It means we are not fixed, that our identity is less a sculpture and more a wave. But it is also freeing, because it means that change is real, that at every moment, the universe carries with it not just what is, but what could be, and that perhaps the most real thing about you is the trembling uncertainty of who you might become. So next time you stand at a crossroads, emotional, spiritual, existential, remember the violin string, remember the cat in the box, remember the particle that dances in all places, in all spins, in all states, until someone dares to look. And maybe, in those moments of uncertainty, don't rush to collapse. Stay open. Stay indeterminate. Let the wave hum. Let the music build. You are more than one path. You are the whole field. And maybe, just maybe, the most powerful thing you can do is wait before you choose which note to play. You can't know a particle's speed and location at the same time. Imagine trying to capture a lightning bolt in your hands. Not its image, not its echo, but the precise dance of energy that streaks across the sky and vanishes before your thoughts. Can even name it, and just when you think you've caught it, it slips through your fingers because you looked too closely, because your grip insisted on knowing both where it is and where it's going, when the universe never promised to give you both. This is the ghostly tension at the heart of the uncertainty principle, a rule of quantum reality that feels more like a koan than a law of physics. According to Heisenberg, at the smallest scales of existence, nature refuses to reveal everything at once. The more precisely you know a particle's position, its place in space, the less precisely you can know its momentum, its movement, its intent, its direction, and vice versa. It's not a flaw in your instruments or a gap in your knowledge. It's not about better lenses, faster sensors, sharper minds. It is the fabric of reality itself, pulling back the curtain just enough to taunt you with the idea of certainty before vanishing again into probability. In a universe built on quantum rules, there is no hidden blueprint that explains all things. There are only shifting shadows that become sharper when you stop looking for the others. The uncertainty principle is not a statement about measurement. It is a statement about what is. To grasp this is to feel the ground shift beneath the entire scientific method. For centuries, science chased the dream of determinism, that if you knew the initial conditions well enough and the laws that governed them, you could predict the future with flawless precision. Like billiard balls on a table, the world seemed to be a machine, each cause birthing an effect, each motion unfolding like clockwork. Newton gave us that model, and for a time, it worked spectacularly. But at the quantum scale, the machinery collapses. The metaphor of gears and levers disintegrates. Here, particles don't obey. They suggest. They don't follow. They offer possibilities. And Heisenberg's principle is the wall you crash into when you try to bring classical expectations into a quantum realm. You want to know where a particle is and where it's headed. The universe answers, choose one. You cannot have both, because the very act of knowing one alters the landscape of the other. The wave function, that strange mathematical ghost that describes all possible states of a system, spreads out like a whisper until observed. And the moment you touch it, the moment you seek certainty, the probabilities collapse, and with them, the doors to every other version of what might have been. This uncertainty isn't just mathematical, it's existential. It mirrors the contradictions in how we live, how we think, how we love. Have you never tried to pin down your purpose, only to feel your passion slip away as soon as you forced it into a plan? Have you never tried to understand someone you love too deeply, only to find the mystery that drew you to them dissolve under the microscope? To observe too much is to disturb. To demand clarity is to forfeit complexity. The human desire for control, for precision, for exactitude. These are powerful instincts, born from a world that rewards mastery. But in the quantum world, and perhaps in the emotional and philosophical worlds we inhabit too, certainty is a mirage. The more we insist on knowing everything, the less we can truly grasp. Heisenberg's principle teaches that knowledge has a cost, not in money or time, but in sacrifice. Every truth you gain comes with a truth you lose. In physics, that trade-off is built into the equations. In life, it plays out in subtler ways. The more you define your identity, I am this, not that, the more potential selves you must abandon. The more you lock into a path, the more you close the door to all the others. The more you dissect your memories, the more they reshape themselves under scrutiny. The past, like the particle's position, solidifies only when you fix it with your gaze. Until then, it is a cloud of interpretations, drifting. The uncertainty principle may describe subatomic particles, but it echoes in every moment we try to define ourselves too tightly, too completely. We become blurry when pursued too closely, even to ourselves. And yet, uncertainty is not chaos. It is a different kind of order, a deeper, humbler one. It suggests that reality is not made of things, but of relationships. Not of solid particles, but of shifting probabilities that become what they are through interaction, through observation, through participation. We are not passive observers standing apart from the world. We are participants whose questions shape the answers. At the quantum level, the observer cannot be removed. And maybe that's true at the human level too. Maybe how you look at someone changes who they become. Maybe how you frame a question shapes the truth you find. Maybe the world is not out there, waiting to be captured, but in here, unfolding as you engage it. This realization, that knowledge is inherently limited, should feel like a defeat. But strangely, it feels like an invitation. If certainty is unreachable, then wonder becomes the default. If the world will never fully reveal itself, then mystery is not a failure of perception, but a feature of the design. The uncertainty principle doesn't say you can't know. It says you can't know everything at once, and in that crack, possibility blooms. It suggests a reality that is richer than facts, a life that is more than measurement. It says you are not here to master the universe, but to dance with it, to navigate it not like an architect imposing structure, but like a musician improvising within a key, aware that every note chosen means another not played. So when you next feel the ache of not knowing, of not being able to pin something or someone down, remember the lightning. Remember that trying to grasp it destroys its shape, that trying to hold too tightly collapses the dance, that some truths glow brightest when glimpsed from the edge, when respected from a distance, and that sometimes the most honest thing you can say is, I don't know both. I can know one. I can sense its motion, or I can know its place, but never both. Not because I am weak, not because I failed, but because the universe itself insists on that limitation. And maybe, just maybe, that limitation is the most truthful kind of freedom there is. The observer creates the outcome in quantum systems. Think of a mirror in the middle of a forest, one that reflects not what is, but what you expect to see, shaped not by light, but by attention, not by angles, but by intention. And the moment you peer into it, the landscape changes, not just your perception of it, but the very arrangement of trees, the color of the sky, the curvature of the earth itself bends to the gaze. This is not a metaphor for magic, but for quantum mechanics. In this strange realm of the infinitesimally small, particles do not behave like tiny marbles waiting to be found. They exist as clouds of possibility, as probabilities smeared across time and space until someone looks, and then, like a breath drawn too sharply, reality collapses into a specific form. This is not an act of passive witnessing, it is participation. Observation, in the quantum world, is not the act of opening your eyes to what was always there. It is the act of choosing, collapsing, cutting through the infinite tapestry of potential, futures, and saying, this one. Before the observer, reality is not undecided, it is undefined, and that shifts everything we think we know, not just about science, but about what it means to be. In the classical world, things exist whether or not we see them. A tree falls in a forest, and physics says it still makes a sound. But in quantum mechanics, the question is more delicate. What is the tree before it's observed? A photon is not a particle traveling through space. It is a wave function, an equation, a mathematical ghost that represents every possible place it could be. When you do not look, it is in many places, many states. When you measure it, the wave function collapses. It is no longer a could be, but it is here. The mere act of measuring strips the universe of ambiguity. It's not that reality hides behind a veil and reveals itself when you knock. It's that the veil is all there is until you reach out. The observer is not a detective uncovering clues. The observer is a creator, summoning facts from fiction, substance from shadow. What's astonishing is not that this happens occasionally, but that it's foundational. It's how reality itself works at its core. Take the classic double-slit experiment. Fire electrons through a barrier with two openings, and they act like waves, interfering with themselves, creating patterns on a screen like ripples on a pond. But place a detector at the slits to see which path each electron takes, and the interference vanishes. The electrons behave like particles. Just asking the question, which slit did it go through, forces the universe to answer with a single path. The act of observing doesn't just record what happens, it changes what happens. The observer alters the observed, and not gently. Reality rearranges itself in response to curiosity. This is not some fringe idea. It has been tested, verified, measured, and remeasured in labs around the world. Quantum systems do not resolve into definite states until they are observed. Until then, they are clouds of maybe, dreams of existence. And yet this principle does not stop at particles. It echoes into the realm of consciousness. If the act of observing shapes what is, then what does that mean for us, the ultimate observers of our own experience? Are we shaping not just the quantum foam, but the structure of our own narratives, our identities, our memories? Every time you recall a moment from your past, your brain doesn't retrieve a file. It reconstructs the memory, reshaping it with each retelling. Observation modifies the past. Neuroscience and quantum theory whisper the same uncomfortable truth. Awareness is not passive. It is active, creative, possibly even directive. The more we understand the brain, the more we see that consciousness is not a spotlight that reveals the stage. It is the playwright, writing the script as it shines. This blurring of boundaries between seer and seen raises questions that border on the theological. If the observer creates outcomes, then where is the line between object and subject? Are we distinct from the world we measure, or woven into its very threads? In a quantum system, no event has occurred until it has been observed. But what constitutes an observer? Is it a conscious mind, a camera, a photon bouncing off an eye? Some interpretations of quantum mechanics, like the von Neumann-Wigner hypothesis, flirt with the idea that human consciousness itself is required to collapse the wave function. Others propose that any irreversible interaction does the job. And yet, the mystery remains. Before interaction, particles are not simply waiting to be revealed. They are undefined. Observation doesn't uncover reality, it defines it. This principle breaks the idea of a pre-written universe. It says the cosmos is not a finished book we're leafing through, but a blank page that responds to the reader's glance. It means we are not just products of the universe. We are participants in its unfolding. The observer becomes a co-author of the script. In the lab, this is measurable. In life, it is poetic. You shape your relationships by how you perceive them. You mold your future by what you believe about it. You become who you are in response to the questions you dare to ask yourself. Just as the quantum world responds to measurement, your identity responds to awareness. What you name becomes real. What you ignore remains in potential. To observe is to choose what becomes real. And that choice, conscious or not, is power. But this power comes with responsibility. If the observer affects the outcome, then the way you look at others can shape who they become. Treat someone as capable, and they rise. Treat them as untrustworthy, and they shrink into that space. The gaze is not neutral, it is a force. Every glance, every interpretation, every framing carries weight. You are not a camera recording what is, you are a mirror, a magnet, a sculptor. The world reflects back the questions you ask it. If you ask, why is everything broken? You will find endless cracks. If you ask, what can be built? The universe opens doors you didn't know existed. The observer effect is not just physics, it is philosophy. It is psychology. It is your everyday existence, disguised in quantum clothing. And so we find ourselves staring into the mirror again, not the one in the forest, but the one inside. The mirror that shows not your face, but your focus. Not your features, but your framing. The one that doesn't just reflect your reality, it shapes it. The quantum world is not otherworldly. It is this world, stripped of its assumptions. It is the world beneath the world, whispering that nothing is fixed until it is noticed. That possibilities remain open until attention arrives. That you, merely, by looking, are bending the fabric of what is. And if that doesn't make you pause, if that doesn't place awe in the center of your being, then you haven't truly looked yet. Particles have no set properties until measured. Imagine walking into a room where every object only becomes real once you notice it. A chair that remains undefined until you intend to sit. A lamp that only gains shape when you reach to switch it on. Walls that are not solid but spectral until your presence makes them so. And every step you take is not through a pre-existing space, but through a landscape actively woven by your awareness. This is not the premise of a surreal dream, but a reflection of one of quantum physics' most unsettling truths. That particles, the very building blocks of reality, have no definite properties until they are measured. They do not possess a fixed position, a precise momentum, or even a decided spin until the act of observation collapses their wave of possibilities into a concrete outcome. Before that point, they are not here or there, fast or slow, up or down. They are, in the deepest sense, undefined. They exist in a haze of potentialities, a probabilistic fog where countless versions of themselves coexist in superimposed ambiguity, awaiting the moment when a question is asked, a measurement made, and nature commits to an answer. The particle does not travel a single path through the universe. It explores them all until it is forced to choose. And it is this very act of measurement, of peering into the quantum mist, that precipitates reality into being. This idea that the properties of particles do not pre-exist their measurement violates the most basic intuitions we carry about the world. We expect the moon to be there whether or not we look at it. We believe that objects possess qualities, mass, speed, color, temperature, that are intrinsic and independent of whether anyone notices them. But quantum mechanics suggests otherwise. It tells us that before a photon's polarization is measured, it does not have a definite polarization. Before an electron's location is checked, it is not anywhere specifically. It is everywhere it could be, in a probabilistic sense. The wave function, a mathematical entity used in quantum mechanics, describes this haze of potential states. It doesn't tell us where a particle is. It tells us where it might be found if we decide to look. And when we do look, that wave function collapses, not gradually, not subtly, but instantaneously, into a single outcome, one location, one state, one version of reality. This isn't just abstract theorizing. It's been tested again and again. In Bell test experiments, physicists have shown that particles that are entangled can instantaneously influence each other's states across vast distances in ways that defy any idea of pre-existing local properties. If particles had set traits prior to being measured, these effects would not be observed, but they are. What we find instead is a world in which outcomes are not revealed, but decided at the moment of observation. The implications are staggering. The universe is not a static machine ticking away behind the scenes. It is an unfolding drama in which each act is written only as it is performed. The properties of matter are not inked into the fabric of existence. They are drawn in real time by the artist's hand the moment the canvas is lifted. And what is this artist? The measurement, the interaction, the inquiry. The moment when a quantum system is forced to answer a question, it does so by adopting one of many possible realities. Until then, it defers, it floats, it dreams in superpositions. Even the spin of a single electron, whether it points up or down, is undefined until it is measured. Prior to that moment, the particle embodies both options simultaneously, existing in a blur that is not indecision, but an inherent feature of quantum behavior. To call it uncertainty is to undersell the strangeness. It is not that we don't know the particle's state. It's that the state does not exist in any singular form until it is brought forth by observation. Reality is not hidden. It is undetermined. This leads to one of the most important philosophical questions in modern physics. Does the act of observation create reality? If the properties of particles are undefined until measured, then in what sense do they exist before we look? Are they merely potentialities, mathematical ghosts waiting to be summoned into form? And if so, what does that mean for the nature of the universe? Are we explorers discovering what is already there, or are we co-creators shaping what comes into being? The quantum world seems to whisper that our questions are not neutral, that every act of inquiry disturbs the balance, changes the outcome, spins the wheel of possibility. To observe is to affect, to measure is to participate. The observer is never detached. They are entangled with the system they examine. In everyday life, we are insulated from these quantum uncertainties by the sheer scale of things. A baseball has a defined position and velocity because it contains trillions upon trillions of quantum particles whose uncertainties average out. But at the fundamental level, where particles blink in and out of existence, where matter is less substance than shadow, the rules are different. There, the universe is less a clockwork machine and more a question still being asked. And perhaps this is not just a fact about physics, but a mirror for our own minds. How often do we assume our identities, our emotions, our decisions are fixed properties? How often do we forget that much of who we are remains undefined until we are challenged, observed, reflected upon? Just as particles crystallize into reality under scrutiny, so too do our values, our priorities, our truths take shape under pressure. You are not just what you are. You are what you become when the moment calls upon you. The quantum world suggests a radical humility. It tells us we cannot speak of what is without acknowledging our role in bringing it forth. It tells us that properties are not fixed, but fluid, that certainty is not a given, but a negotiation between what could be and what is demanded. And it invites us to let go of the illusion that the universe is fully formed, waiting to be surveyed. Instead, it offers a view in which existence is participatory, dynamic, responsive. Measurement is not a window, it is a brushstroke. Observation is not a lens, it is a chisel. The observer is not standing outside the frame, they are inside it, shaping it, living it. And so we return to that room where reality remains blurred, unformed, until you enter. You reach for a switch, and only then does light emerge. You extend a hand, and only then does the object materialize to meet it. Every step you take does not follow a fixed map. It creates the path beneath your feet. Particles, it seems, are not reluctant to be known. They are incomplete until they are. And perhaps so are we. Quantum tunneling. Particles pass through barriers. They shouldn't. What if the walls you thought were impenetrable, the locked doors of fate, the ceilings of possibility, the concrete barriers between where you are and where you long to be were not as solid as they seemed? Imagine walking toward a towering stone wall, one that has stood for centuries, and realizing that if you do not stop, if you press forward with enough certainty, you might, against all expectation, pass through it. Not around it, not over it, but through it. This is not a metaphor invented for inspiration. It is a principle embedded in the fabric of our universe, whispered by particles too small to see, too elusive to predict. Quantum tunneling is the stunning revelation that, in the realm beneath perception, boundaries are negotiable, and even the laws of classical logic bow to something deeper, stranger, and far more forgiving. In the world of the very small, particles are not bound by the rules we impose on them. They do not always respect the notion that you must have enough energy to climb a hill before reaching the other side. Sometimes, they simply disappear from one side of the barrier and appear on the other, as if the wall they were supposed to bounce off of never existed at all. This is not magic. This is quantum mechanics. At the heart of tunneling is the concept of probability. In classical physics, a ball rolling toward a hill will only make it to the other side if it has enough energy to reach the peak. If it doesn't, it rolls back, defeated by gravity and friction. This is the universe we know, predictable, restrained, grounded in determinism. But quantum mechanics offers another version of reality, one in which particles are not confined to definite paths, but are instead described by wave functions that stretch across space, assigning probabilities to every conceivable location. These waves do not end at barriers, they only decay. And as long as the wave continues to exist, even faintly, on the other side of a barrier, there remains a chance, however small, that the particle can be found there. It doesn't climb over. It doesn't break through. It tunnels. The particle, in some very real sense, stops being a particle at all and becomes a whisper of potentiality, an echo of what could be. And sometimes, the universe answers that echo. This behavior is not just theoretical, it is essential to how our world works. Quantum tunneling enables nuclear fusion inside the sun, where hydrogen atoms overcome repulsive forces to bind together, releasing the light and warmth that sustains life on Earth. Without tunneling, that fusion would never occur, and the stars would remain dark and cold. Tunneling is also the reason why semiconductors and transistors function, the very foundation of the digital age. The device you're reading this on would not exist without the ability of particles to slip through energy barriers they shouldn't cross. And yet, despite its ubiquity, tunneling remains profoundly counterintuitive. It defies our everyday expectations that effort should match result, that force should be met with resistance, that barriers should block what is not strong enough to overcome them. Quantum mechanics rewrites that script. It whispers that the world is not built of walls, but of probabilities, and those probabilities sometimes allow for the impossible to occur. But beyond the mathematics, quantum tunneling invites us to reconsider something deeply human, our relationship with limitation. How often do we treat circumstances as absolute? How often do we accept the verdict of reality too soon, mistaking delay for denial or resistance for finality? We encounter emotional barriers, social walls, psychological ceilings, and we stop. We tell ourselves that progress requires power, that change demands force, that anything worth reaching must be earned with overwhelming energy. But the quantum world suggests a different path, that persistence, presence, and probability can sometimes achieve what brute strength cannot. That existence itself is not a series of fixed outcomes, but a field of fluctuating chances, where even the most impassable boundary may harbor a faint echo of escape. And perhaps this is where metaphor and mechanics meet most intimately. Quantum tunneling does not promise guaranteed outcomes. It offers possibility in the face of improbability. It reminds us that a system doesn't need certainty to change. It needs only a sliver of amplitude, a whisper of potential, a flicker of chance that refuses to be zero. And that is often enough. In a universe where particles can pass through forbidden regions simply because their presence there is not entirely ruled out, we are invited to wonder what barriers in our own lives are only as real as our acceptance of them? What walls persist only because we turn back at their edge, never testing whether the world might yield under a more subtle form of movement, not a forceful push, but a quiet persistence? The strange beauty of tunneling is that it preserves a kind of grace. It doesn't smash, it doesn't invade, it doesn't conquer, it permeates. It slides between the cracks of what should be, not to destroy structure, but to reveal that structure was never as absolute as we believed. In this way, quantum tunneling is not just a physical process. It is a philosophical whisper about the malleability of reality. It is a reminder that even laws have loopholes, that even rules leave room for uncertainty, and that within the space between yes and no lies a narrow corridor where miracles happen. Not loudly, but silently, not through might, but through possibility. And yet the implications go even further. If particles can tunnel, then so too can information, influence, even identity. Tunneling challenges the notion of separateness. If a particle is here and then suddenly found there, without crossing the space in between, what does that say about continuity, about presence, about movement itself? It suggests that the fabric of the universe may be less about sequence and more about connection. That the spaces between are not voids, but veils. And behind those veils, everything is entangled in a dance of potentialities, waiting for the right question, the right context, the right moment to become real. So much of our experience is bounded by the illusion of permanence. We build narratives around the walls of who we think we are, what we believe we deserve, and what we believe is possible. We assume that the past is fixed, that the future is far, that the present is solid. But tunneling hints that time, like space, is not a prison, but a palette. That change does not require destruction. It only requires allowance. That presence is not limited by position, and movement is not limited by momentum. The particle does not ask whether it can. It simply exists within a framework where maybe is enough. And perhaps we too can learn to live in the space of maybe. To tunnel is not to deny the wall. It is to recognize that the wall does not own all outcomes. It is to understand that being blocked does not mean being stopped, that encountering resistance is not the same as reaching the end. It is to inhabit possibility with patience, to trust in the unseen mechanisms that may allow passage when logic says none exists. And this is not blind optimism. It is quantum wisdom. It is the mathematics of humility, the physics of faith, the science of the improbable. It is the universe reminding us that no structure is absolute, no limitation eternal, no separation insurmountable. Even in the darkest depths of what should be impossible, the wave function continues, faint, fading, but never extinguished. And that alone is enough for something to pass through. Quantum randomness, not even the universe, knows what happens next. Imagine tossing a coin in a world where even the coin doesn't know which way it will land. Not because it's mid-air, not because of wind, friction, or flawed prediction, but because the very fabric of reality itself hasn't decided yet. Imagine a casino run by the universe, where the roulette wheel spins without rules, the dice fall without weight, and every outcome emerges from a void not of mystery, but of true indeterminacy. This isn't fantasy. It's the bizarre playground of quantum mechanics, where randomness isn't just a gap in human knowledge, but a fundamental property of existence. In the quantum world, events do not unfold according to strict, knowable chains of cause and effect. Instead, they shimmer on the edge of potentiality, waiting not to be determined, but to simply happen. There is no hidden script, no backstage director pulling levers behind particles. What occurs, when, where, and how, is born not from necessity, but from sheer probabilistic spontaneity. The spin of an electron, the decay of a nucleus, the path a photon takes through a crystal, all emerge not because they must, but because they might. And in that tiny space between might and must, our entire understanding of determinism crumbles. For centuries, science sought to tame the universe into a machine, gears grinding in unison, every motion the result of some prior push. Newton's laws gave us a cosmos of consequence, predictable, mechanical, graspable. If you knew everything about a system, you could predict its future with perfect accuracy. The universe, it seemed, was a giant clock, and with enough data, we could wind it forward or backward at will. But quantum mechanics shattered that illusion. in its equations, particularly in the Born rule, which translates the mathematics of wave functions into observable outcomes, we find not certainty, but probability. A particle might appear here or there, spin up or down, decay now or later. Nothing, not even the laws of physics, can say in advance which. This isn't ignorance. It's not that we don't know, it's that the universe itself doesn't know, until the moment happens. And even then, the decision doesn't come from a hidden variable or an unseen cause. It arises from chance, pure and unapologetic. Take radioactive decay, for example. An unstable atom sits quietly, no external disturbance, no change in temperature or pressure, and then, suddenly, it emits a particle, transforming into something new. Why then? Why not earlier? Why not later? There is no answer, no deeper mechanism. The best we can do is assign a half-life, a statistical average. The rest is left to randomness. This isn't a defect of theory, it's a revelation. At its core, quantum randomness tells us that some things just happen. They don't have to. They don't not have to. They just do. And in that simple truth lies one of the most profound philosophical challenges ever faced by science. A universe that is not fully predictable is a universe that is, at least in part, unknowable. Not just to us, but even to itself. Einstein famously resisted this. God does not play dice with the universe, he protested, unable to accept that reality might rest on a foundation of uncertainty. But experiment after experiment, Bell's inequalities, quantum erasers, photon polarizations, confirmed what the math had suggested all along: the dice are real. And they're not just in God's hands. They're built into the architecture of existence. This isn't chaos. It's a different kind of order. One where possibility, not certainty, is the bedrock. Where the future is not written in the past, but co-authored in the instant of becoming. And this randomness is not confined to obscure laboratories or esoteric particles. It reaches into everything. The chemical reactions that drive life, the quantum fluctuations that seeded galaxies, the neurological noise that may underlie free will, all draw from this well of unpredictability. Every breath you take, every thought you form, might be riding on a ripple of quantum chance. It is sobering, even disorienting, to realize that beneath the world of objects and events lies a substrate that resists order. We like to think of the future as a consequence of the past, a sequence, a chain. But quantum mechanics invites us to see it as a garden of forking paths where the route ahead is not chosen but discovered. This has unsettling implications. If even the universe can't predict what happens next, what becomes of causality, of meaning, of control? We often equate randomness with meaninglessness, but that is a bias born of our discomfort with not knowing. In truth, randomness may be the space where creativity lives. It is the crack in the system that allows novelty to emerge. A world of total predictability would be a frozen one. No surprise, no choice, no deviation. But a world with randomness breathes. It adapts, it evolves. Evolution itself is driven by mutation, which at the genetic level arises from quantum-level uncertainties. Consciousness, too, may be flavored by quantum noise, adding a flicker of spontaneity to thought. In this sense, randomness is not the enemy of reason. It is the mother of all that is new. Still, the human mind resists. We crave patterns. We find comfort in cause and effect. Our brains are prediction machines, constantly scanning the future for clues, rehearsing outcomes, calculating risk. But quantum randomness humbles that impulse. It tells us that not everything can be foreseen, not every question can be answered, not every outcome can be controlled. This is not a flaw, it is an invitation to live not in fear of uncertainty, but in relationship with it, to walk not with a map, but with a compass, to act not because the result is guaranteed, but because the act itself is worthwhile. And in this way, quantum randomness becomes a metaphor for human experience. We do not know what will happen when we speak a truth, take a risk, love someone, leave something behind. We cannot. The variables are too many, the interactions too subtle. But still we act. We choose. We step forward into the unknown, hoping that somewhere within the space of possibility, something meaningful will unfold. That is quantum courage, the willingness to leap without knowing where we'll land. Not because we trust in certainty, but because we trust in potential. So what does it mean, ultimately, that the universe contains true randomness? It means that the cosmos is not a machine, but a dance, not a code, but a conversation. It means that within every moment lies not just what is, but what might be. And while we cannot control that randomness, we can learn to live with it, to find grace in uncertainty, to make peace with mystery, to stop demanding that every answer be knowable and start embracing the beauty of not knowing. Because in that space of not knowing, in that flicker before the outcome, life happens, art happens, love happens. And sometimes a particle chooses a path that no law could have predicted, not because it was forced, but because it was free. Quantum erasure. You can erase information after it's recorded. Imagine walking into a vast, ancient library where every book writes itself the moment you read it, yet vanishes if you forget having ever opened it. Imagine memories inked not, in permanence but in possibility, flickering, conditional, and reversible. Now imagine a universe built on that logic, where information isn't an absolute, but a suggestion, where reality isn't merely shaped by what you observe, but also by whether you choose to preserve the record of that observation. This isn't a parable. It's the perplexing truth behind one of quantum physics' most unsettling revelations, quantum erasure. In this strange corner of the quantum world, you can measure a system, learn something real about it, and then, by deleting the context of your observation, undo the consequences as if the measurement never happened. It's as though the universe itself allows you to rewind causality, not by turning back time, but by erasing the meaning of having ever looked. And in doing so, it raises a haunting question. If reality only congeals around the information we choose to keep, what else are we unknowingly letting dissolve? At the heart of quantum erasure is the dual nature of particles, the ability for photons, electrons, and atoms to behave as either particles or waves, depending entirely on how they are observed. This duality lies at the foundation of quantum mechanics, most famously illustrated by the double-slit experiment, where particles fired at a screen through two slits form an interference pattern, like ripples of water overlapping, unless you observe which slit they go through. The moment you measure the path, the pattern collapses. The wave disappears, and the particle acts like a discrete object. This suggested a disturbing truth. Observing a quantum system doesn't just reveal its state, it changes it. But what if you could undo that change? What if you could record the which path information, then later choose to erase that information and watch the wave pattern reappear, as if you had never looked at all? That's the quantum eraser. In these experiments, particles are entangled, linked, in such a way that measuring one immediately affects the other, regardless of the distance between them. Imagine a pair of entangled photons. One heads to a detector that measures its path through a double-slit setup, while the other flies to a distant device that either preserves or erases the which path data. If the path information is kept, the interference pattern vanishes. But if the information is erased, even after the first photon has already hit the detector, the interference returns. The mere act of removing knowledge restores the wave behavior, not just metaphysically, but visibly, measurably, undeniably. Somehow, the universe behaves as if the past is contingent on whether we decide to preserve the memory of it. It doesn't. Rewrite history. It lets the past exist in a superposed state until we either choose to confirm it or choose to forget. This idea doesn't merely strain logic, it rends the fabric of linear time. Because in quantum erasure, decisions made in the present affect the interpretation of events that have already occurred. The The future, in a very real sense, reaches backward and reshapes what was, not by changing the particles themselves, but by altering what we're allowed to know about them. It's not time travel, it's time ambiguity. The particles passed. Reality remains fuzzy until the observer resolves whether the measurement counts. And that decision, even if made after the detection, seems to determine whether the particle behaved like a wave or a point. We are forced to entertain a truth far more radical than we're comfortable with, that observation does not merely collapse a wave function, but perhaps, by erasing it, uncollapses it, revives its ghost, and sets possibility back in motion. This is not a loophole or a trick of data. Quantum erasure has been demonstrated in the lab. Delayed choice quantum eraser experiments, like those devised by Yoonho Kim and colleagues, show this effect with breathtaking clarity. Information is not a passive result of measurement. It is an active agent in the unfolding of reality. And when that information is discarded, the consequences vanish with it. But what is information? Is it the physical imprint of photons on a screen? Is it the electronic states of a detector? Or is it something more abstract, something dependent on whether a conscious observer could, in principle, know the result? These questions bleed into philosophy, into cognitive science, into epistemology. Because if the act of erasure alters what was, what happens when we forget? What happens when no one looks? What if your memories, your perceptions, your understanding of reality all hinge on choices not yet made? The metaphors are dizzying. It's as though we're watching a movie, but the plot only stabilizes when we commit it to memory. Until then, every scene is still in flux, every character uncertain, every twist provisional. The film runs backward and forward at once, collapsing only when we say, yes, this happened. But if we later say, no, I didn't see that, the reel rewinds and plays a different version. Quantum erasure does not suggest that we can change the past. Rather, it tells us the past was never fixed to begin with. It was waiting for us to decide whether to remember. This has profound implications for how we think about causality, agency, and even ethics. In a world where knowing shapes being, where deleting knowledge alters behavior, responsibility itself becomes a spectrum, not a binary. If we know that knowing changes things, are we culpable for choosing ignorance? If we erase the context of a choice, do we also erase its weight? Are our regrets and our reliefs equally subject to quantum contingency? These questions, once confined to theology or existential philosophy, now sprout from the very roots of physics. But perhaps the most intimate implication is psychological. Our brains too are information processors. They observe, record, delete. Memories fade. Awareness sharpens or slips. Trauma is buried. Joy is forgotten. Is our personal reality also shaped by quantum-like erasures? Does forgetting allow a new narrative to form, not because we invent it, but because the old one ceases to exist in the absence of attention? In this light, healing may not be rewriting, but unknowing. Letting the collapse reverse, letting the pattern reappear. And in this lies a paradox both haunting and hopeful. If observation defines reality and erasure undefines it, then we are both sculptors and erasers of our world. We do not merely walk through a pre-written story. We help write the words, and sometimes we choose to smudge the ink. The universe, it seems, is not a ledger, but a living draft. And you, in your quiet choices of what to remember and what to let go, are part of the editing process. You are both reader and author, both witness and eraser. And the final version of your world may depend not only on what you saw, but on what you chose to forget. Quantum interactions are reversible, but the world isn't. Imagine a pristine lake at sunrise, utterly still, mirroring the sky so perfectly that you cannot tell where water ends and the heavens begin. Then toss a stone into it. Ripples spread outward, the surface dances with waves, and the perfect reflection is lost. Now imagine trying to reverse those ripples, to reclaim that original stillness. You'd need to reach out and collect every molecule, every vibration, every photon of light reflected from the surface, and send them all backward with perfect precision. In theory, under the laws of quantum mechanics, that reversal is possible. The microscopic equations that govern particles are time-symmetric. They don't care whether time flows forward or backward, but the world we live in does. The lake never returns to its perfect calm. The ripples don't unsplash. And therein lies one of the strangest paradoxes at the heart of physics. At the quantum level, the universe is reversible. But our macroscopic world, the world of people, of history, of heartbreak and progress, stubbornly flows in one direction, like a river that never turns back. Why is that? Why do the equations whisper symmetry, but reality screams decay? At the heart of this tension lies the difference between what is mathematically permitted and what is physically probable. Schrödinger's equation, the governing principle of non-relativistic quantum mechanics, is perfectly reversible. If you know the wave function of a system at one moment, you can calculate both its future and its past states with equal precision. The evolution of that wave function is deterministic and unitary, preserving all information, that is, unless it is measured. But even then, interpretations like many worlds preserve reversibility by branching instead of collapsing. On paper, the quantum realm respects time like a mirror. What goes forward can, in principle, go backward. Yet the universe we inhabit doesn't behave that way. Ice cubes melt in warm water, but we never see them reform. Buildings collapse in earthquakes, but we never watch rubble reassemble into walls. Memories accumulate, but they don't erase themselves. This asymmetry, this irreversible march of time, is not written into the laws of quantum mechanics. It emerges when many quantum systems interact, when entanglement spirals into chaos, when entropy takes the reins. Entropy, the measure of disorder, is the great arrow of time. It's why you age, why your coffee cools, why stars burn out and civilizations crumble. Entropy increases because there are more disordered states than ordered ones. And given enough time, systems tend to move from unlikely configurations to more probable ones. It's not that atoms can't return to order, it's just fantastically unlikely that they will. Imagine throwing a deck of cards in the air and having them land perfectly sorted by suit and number. It's not impossible, it's just statistically absurd. The same is true of your body, your mind, your memories, your entire life. Every moment you live is an arrangement of particles more disordered than the moment before. Not because those particles can't reverse, but because they almost never do. This, then, is the crack between quantum reversibility and worldly irreversibility. The divide between what is possible and what is probable. Still, quantum mechanics teases us with reversals. Experiments in weak measurement, quantum teleportation, and Loschmidt echoes allow physicists to undo certain quantum states under highly controlled conditions. Quantum error correction can reverse decoherence. Entangled photons can be manipulated to restore previous states. In these rare and delicate circumstances, it's as if the universe momentarily forgets its forward bias. But these are exceptions that prove the rule. Because the moment those systems interact with a larger environment, with air, with light, with you, the information leaks away and reversibility becomes a ghost. Decoherence, the bleeding of quantum information into the environment, turns quantum purity into classical messiness. What begins as a crisp quantum state becomes a blur of probabilities. The world, with its trillions of particles colliding and vibrating and radiating, quickly drowns any chance of rewind. The arrow of time sharpens not at the level of particles, but in the crowd of their interactions. This realization haunts more than just physicists. It haunts philosophers, theologians, psychologists, because it means that while the core of reality may be reversible, our experience of it is not. You cannot unspeak words once they're heard. You cannot unchoose a path once it's walked. You cannot unhurt someone after the pain has been felt. These are not just social truths. They are thermodynamic ones. The emotional entropy of life, the way relationships unravel, the way trust decays, the way moments become memories. mirrors the physical entropy of the universe. There is no cosmic undo button. And yet, knowing that, we ache for it. We imagine time machines, second chances, clean slates, but the universe offers none. It only offers now, a fleeting present sliding irrevocably into a diffused future. Still, there is a kind of grace in this irreversibility, because it gives meaning to choice. If everything could be undone, then nothing would matter. But the fact that our actions echo forward, that our decisions carve irreversible paths into the fabric of time, gives weight to being. The irreversibility of the world makes life not a loop, but a story, with chapters, with consequences, with endings. And stories, unlike equations, are meant to move in one direction. This is the paradox. The universe is reversible, but its meaning is not. You can't return to who you were before you knew grief, or love, or loss. You can't rewind the clock to unmeet someone, or to unlearn a truth that cracked your worldview open. Those transformations are permanent. They are the soul's entropy. Even at the edge of physics, this lesson holds. Black holes, those enigmatic voids of gravity, were once thought to destroy information. But modern theories suggest that information is preserved in Hawking radiation, in holographic horizons, in entangled pairs. Still, recovering that information is so unfathomably complex that for all practical purposes, it is gone. Reversibility, again, remains a technicality. In life too, we retain traces, photographs, journal entries, scars. But those fragments are not the experience. They are echoes, shadows of states that no longer exist. So what does it mean for you to live in a world built on reversible particles, yet flowing irreversibly toward entropy? It means you are a process, not a snapshot. It means nostalgia is inevitable, but resurrection is not. It means the pain you feel in moments of regret is the cost of being a temporal being. And it means that every present moment is precious precisely because it cannot be repeated. Quantum mechanics may offer a blueprint of reversibility, but the architecture of your life is sculpted by one-way time. And so you must make peace with the ripple you send into the lake, knowing it cannot be unmade. Vacuum fluctuations, space boils with ghost particles. Imagine standing in a vast, silent desert under a moonless sky, believing yourself to be utterly alone, surrounded by nothing but empty air and stillness, until, with no warning, the sand beneath your feet shudders, as if something beneath the surface had stirred, unseen and uninvited. That tremble, that unexpected pulse in a place you thought lifeless, is the closest metaphor we have to what happens in the vacuum of space. Because contrary to everything intuition whispers, the void is not empty. Even in its most absolute silence, the vacuum is alive with motion. It seethes, it fluctuates, it boils, not with heat, but with potential. A roiling, restless foam of ghost particles that flicker into existence and vanish again before time can fully register their birth. These are not poetic fantasies or exaggerated metaphors. These are vacuum fluctuations, real phenomena predicted by quantum field theory and confirmed by experiments so delicate they dance on the edge of invisibility. The idea that nothing is truly nothing has long since been exiled from modern physics. In the quantum world, nothingness is unstable, foaming with spontaneous possibilities, a storm of virtual particles that emerge from nowhere and collapse into nowhere, changing the very fabric of the cosmos with every fleeting breath they take. To understand this, you have to shed every notion of emptiness you've ever carried. The classical idea of a vacuum, a box devoid of matter, a total absence of particles and energy, is obsolete. In quantum field theory, every point in space is pervaded by fields. For electrons, photons, quarks, gluons, and even in the absence of particles, those fields remain. But they are not silent. Because of the Heisenberg uncertainty principle, which tells us that certain properties like energy and time cannot both be known with absolute certainty,